Now let's have a look at a second example. This one involves a proof of the calculus identity using mathematical induction. We're going to prove that the derivative of x to the n is n x to the n minus 1, where n is an element of the natural numbers. So we'll start off with let n equal 1. So that's going to give us, left-hand side is the dx of x to the 1. Okay, the derivative of x to the 1 is just 1. Right? Easy way to think about that is, there's y equals x, y equals 1x. What's its slope? It's got a slope of 1. So the derivative of that is 1. Now, let's look at the right-hand side. So the right-hand side is 1, x to the 0, which is just 1. So left-hand side equals right-hand side, therefore true for n equals 1. Okay, now suppose true for n equals k. Okay, so therefore assume that d dx x to the k equals k x to the k minus 1, where k is an element of natural numbers. That's our assumption. Okay, and then this, we're going to prove true for n equals k plus 1. Therefore, required to prove that d dx x to the k plus 1 is equal to k plus 1 x to the k. Okay, so that's what we're going to prove. Alright, we'll start off with the left-hand side. And don't forget, k, element of the natural numbers. Left-hand side is d dx x to the k plus 1. Now, you've got to be careful here. You're going to have to think of this as a product. So, x to the k times by x to the 1. The temptation is just to do this, right? You can't do that because that's what you've got to prove. So don't do that. Think of this as a product, and you're going to use the product rule to differentiate. So, remember the product rule? U dash v plus v dash u is your derivative. So, differentiating this, we're going to get k x to the k minus 1 now I'm going to get d dx x to the k multiplied by x plus x to the k by the derivative of x to the 1. Okay, so d dx x to the k is going to be where we use our assumption, which is here. So I'll put my assumption here, k x to the k minus 1 multiplied by x plus x to the k. Now we know the derivative of x to the 1 is just 1. Alright. Now, that's going to give us k. Now using your index laws here, that's just going to be x to the k plus x to the k. You can see here I've got x to the k as a common factor, k k plus 1, right, which equals so we proved what we had to do. So start off the left hand side and we proved that's equal to the right hand side. Okay, so therefore true for n equals k plus 1 if true for n equals k, since true for n equals 1, d dx x to the n is equal to n x to the n minus 1 for all n natural numbers n bigger than or equal to 1. Okay, so that's it, the second example. Alright, so you can now start the questions on exercise 504 and we'll leave it there for today. See you next week.